In order to close a stomatal guard cell, it has to be open in the first place. Now, this open guard cell will have had its potassium concentration increased by the opening process and its chloride concentration increased by the process of opening. A signal that is known to lead to the closure of guards of stomata is abscisic acid. Abscisic acid, abbreviated ABA, is a hormone. Travels sometimes from the roots up into the shoot of the plant, sometimes other parts of the shoot, but it is a signal that means there's a lack of water. Now, this signal the opening of calcium channels. Calcium enters the cell and has the effect of slowing down, so making it so that less protons are pumped through the membrane by the proton pump. Calcium, however, also opens a channel. Calcium leads to the opening of the chloride channel. Why do you suppose chloride is exiting now? Well, although you've reduced the membrane potential in this cell, or are in the process of reducing it by slowing down the pump, you're also reducing it by allowing more of these negatively charged ions out of here, so that we are, by these two steps, both by slowing down the pump and by letting chloride out, depolarizing the membrane, making it less different across the membrane. Okay, so it was the charge that's driving chloride out and the concentration gradient. Calcium is the signal, so this is a calcium-gated chloride channel, and the pump is being slowed down somehow by calcium. This change in membrane potential, this depolarization, leads to the opening of depolarization-gated potassium channels. And so potassium also exits the cell, not as a result directly of the calcium, but as a result of the depolarization. Nonetheless, both chloride and calcium concentrations then, so these solute concentrations, decrease. And a decrease in solute concentration leads to, or constitutes, an increase in osmotic potential. And an increase in osmotic potential leads to water exiting the cell through aquaporins. And water exiting the cell through aquaporins leads to a decrease in the volume of the cell and therefore, or consequently, a decrease in the pressure of the cell.